All right, we are moving on to section 3.3. The start thinking part, when you're looking at it, it's kind of hard to read, but it actually says, can you read this message? Today we'll explore what happens when we reflect shapes we get them mirror image. Okay, so obviously they have the mirror image because we're going to be looking at reflections today, and reflections result in mirror images. So this first one says, to the right is a triangle on the coordinate plane. Trace the triangle several times with the pencil. Significant amount of graphite is transferred to the paper. Fold the paper along the black horizontal line. Use your fingernail or a coin. Go ahead and rub on that, and then look at the imprint of the triangle. Label the corresponding parts A prime, B prime, C prime. Looks like I forgot to label it A prime, B prime, C prime, but you know which ones line up to which ones. I also didn't do it with graphite. I actually did the reflection, but it still would end up in that same location. It says, in general, what do you notice happens to the figure? It is flipping over the line. Next, what do you notice about the distances from A, B, and C to the folded line versus A prime, B prime, C prime to the folded line? You find that A and A prime are the same distance, B and B prime are the same distance, and C and C prime are the same distance. They're not all exactly the same distance, but they are the same distance that their corresponding part is. So if A is 1 unit above, A prime will be 1 unit below. If B is 3 units above, B prime will be 3 units below, and so on. So that is talking about how the points move, how far they move from the line of reflection when you do a reflection. The next one says, draw a line segment between A and A prime, B and B prime, C and C prime. How do these segments intersect the line of reflection? Well, it looks like they're intersecting perpendicularly, okay? So they are going to be perpendicular. And once again, A going to the line and A prime going to the line is going to be the same distance. B going to the line, B prime is to the line is going to be the same distance. So there's a different way we could even say this. A prime, B prime, and C prime are perpendicularly bisected by the line of reflection. It's cutting it in half and it's perpendicular. Okay. And then lastly, it says, does the triangle change size or shape? The answer is no. So if it doesn't change size or shape, meaning it stays congruent, we know now that this is a rigid motion. It also says the line of reflection is a perpendicular bisector of A prime, B prime, and C prime, as we just talked about. It cuts it in half through the middle, which is cutting it in half, and it's perpendicular. Now, our quick notes are basically a reflection is a flip over a line. Now the notation, big T was translation, so reflection is going to be big R. Then you are going to have a part that says what you are flipping over, whether it's the x-axis, the y-axis, or whatever, and it tells you what is going to be flipping, in this case, triangle ABC. Okay. Now, something that you probably forgot from Algebra 1 is that x equals a number is a vertical line because it goes to the x-axis, and y equals a number is a horizontal line because it goes through the y-axis. Points stay the same distance from the line of reflection so that A prime, B prime, and C prime are perpendicularly bisected by the line of reflection. Okay, let's go ahead and take a look at some. On here, we are first going to do, we did this as a class. So if you are reflecting over the y-axis is the vertical one. Any points that are on the left are going to go to the right the same distance. Any that are on the right are going to go to the left the same distance. So I can't really read this because it is kind of blurry, but it looks like A is 3 units to the left, so we go 3 units to the right. It looks like C, I can't tell, but it looks about 4 units to the left. It's going to go 4 units to the right of the line of reflection, which is the y-axis. And then one last point was actually 1 to the right, so it goes 1 to the left. And when you connect them all, you can see that this would be the shape you would get if you went over and used graphite, traced out the triangle, folded it, and scratched it with your fingernail. Okay, when all else fails, you could always look at that. The next one is reflection over y equals 1. Y equals 1, as we said, is a horizontal line going through the y-axis at 1, so I did that. And then we have 2 points that are below the line, so they have to go above the line the same distance, but we have 1 point that is on the line. It just doesn't move. Since it's 0 units from the line of reflection, it stays 0 units away on the other side, which is just on the line. Now this last one messes people up a bit. And also, this is kind of hard to see. If you're looking at your notes, it'll make more sense. So the reflection over y equals x. Well, y equals is a number is horizontal, x equals a number is vertical, so y equals x is actually a diagonal line, and it is just one with a slope of 1. So you want to go, let's say, up 5 over 5 and put a point and connect it with 0, 0. And the reason why we're doing that is because we have a slope of 1. That is what y equals x means. Now, if the slope of the line of reflection is going to be 1, then the slope of AA prime, BB prime, and CC prime is going to be negative 1, okay? Meaning kind of like the same diagonal, but going down with the same slope. Now, this is hard for me to show in this example, but basically what you do is you count the number of diagonals it takes to get to your line, in this case, when you're reflecting over y equals x or y equals negative x. So C, if you counted it, would be a full diagonal to get to the line. So you continue a full diagonal, and then you would get to C prime. I cannot count these because it's just I can't see it, it's too foggy. But basically, I think that B might be like 3.5 diagonals to get to the line. So you do 3.5 diagonals to get to B prime on the other side. So sometimes it'll be full diagonals and sometimes it'll be part of diagonals. When you're looking at your actual notes, you'll be able to count the diagonals. Going across from the top left to the bottom right is a diagonal. Okay, so that makes sense. The only difference would be if you had y equals negative x. That would be a line that looked like this one, but was actually going through 0, 0 and had a negative 1 slope. So that's probably the hardest out of all of them. Or this is probably the hardest. You have an algebra connection. So it says after a reflection, A is located at 1, 8, and A prime is located at 5, 10. What is the equation of the line of reflection? Hint, what do you need? Or you need a point and a slope to write the equation of a line. So really we need to know a slope of the line of reflection, and we need to know a point on the line of reflection. Well, as you can see in my little drawing there, A and A prime, if you drew the line segment, it would be perpendicularly bisected by the line of reflection, meaning the line of reflection will go through the midpoint, and it is also going to be perpendicular. So one thing you can do is find the slope of AA prime, because you have both points, and in this case you find out the slope is 1/2, and that tells you the slope of the line of reflection since it's perpendicular. What we learned last chapter was that you flip the slope and switch it from positive to negative or negative to positive. So that would get you -2. The midpoint is going to be 3, 9. So if you have 3, 9 and a slope of -2, you can just solve for B, and you see my work there, and I got y equals -2x plus 15. Hopefully that made sense. Once again, the AA prime, BB prime, and CC prime are going to be perpendicularly bisected by the line of reflection. Let's check your understanding. So on this one, you were supposed to reflect over the y-axis. So you had a bunch of points above. They all have to go below the same exact distance. The next one, you're reflecting over y equals x. You're going to count the diagonals, whether I think that first point on the top of the triangle for B, for problem B, is a half a diagonal. So you go a half a diagonal in the opposite direction. You're just counting the number of diagonals. And that makes it so that AA prime, BB prime, and CC prime would all be perpendicularly bisected by the line of reflection. And our last one is x equals -1. That is a vertical line going through -1. Any points on the left go to the right, any points on the right go to the left, same distance away from the line of reflection. Okay. And the last one says triangle DEF has a coordinate given by D is 2, 7, E is 3, 4, and F is -1, -2. When DEF is reflected across a certain line E, E prime stays in the same position. The triangle has been reflected over a vertical line. What is the equation of the line? When you think about this, it's a vertical line, and E has not gone over and moved. Therefore, E must be on the line of reflection. So we know the line of reflection goes through 3, 4. So if it's going through 3, 4 and it's a vertical line, you can see that has to be x equals 3. Vertical line is x equals, and it goes through at 3. Hopefully that made sense. Now for our homework really quickly, circle all that apply. Which of the following are true about reflections? Are the pre-image and image congruent? Yes. Is the orientation flipped? Yes. Are all points move in the same direction? Yes. All points move the same distance? No. The distance from A to the line of reflection is the same as A prime to the line of reflection. Yes. And all points must move. No. If there's a point on the line of reflection, it does not move. For number 2, you need to remember that the x-axis is that horizontal one. So any points above go below, any below go above the same distance. On B, y equals x is a diagonal line going, you have a slope of 1, so go up 1 over 1, up 1 over 1, up 1 over 1, and make your line. And then you count the diagonals to get from your points to the line of reflection, and count the same number of diagonals on the other side, and that's where your new point will be. If all else fails, there's nothing saying you can't trace it out and fold it and see if the points end up where you thought they were supposed to be. And then on the next one, it is reflect over x equals 1. That is a vertical line going through 1. And any points on the left go to the right, any points on the right go to the left, and any point on the line of reflection does not move. Pretty little butterfly look, or bow tie. Now on this one right here, it says give a possible location of A and A prime given a line of reflection of y equals 3. So if you have y equals 3, that is a horizontal line at 3, and you're going to have a point above or below unless you said that the point was on the line of reflection. So if it's on the line of reflection, any point that is on y equals 3 after the reflection would be exactly in the same location. I decided not to go that route. I said 0, 2 and 0, 4, and basically you have to have whatever you gave. The x's have to be the same because when something reflects over a horizontal line, the x does not change. So make sure that your x's are exactly the same, and then your y's have to average to be 3 because one will be above, one will be below, and right in the middle of them will be your line of reflection. So just check, are your x's the same? Are your y's averaged to be 3? If so, then your answer is correct. Number 4, what is the equation of the line of reflection if A is located at 2, 4 and A prime is located at 14, 8? Well, just like the problem that we did earlier, you're going to have to find the midpoint and the slope of AA prime. So the slope of AA prime is 1/3, and that means the slope of the line of reflection is -3. The midpoint is going to be at 8, 6. So what you had to do was go ahead and find the equation of the line that has a slope of -3 and a point of 8, 6. And when you do that, you end up getting a y-intercept of 30. All right, hopefully that made sense. Thanks for watching.